Hi, welcome everyone. Sorry for the delay and thank you for joining today's webinar. We're excited to get going. So my name is Patrick Kenny and I'm the Senior Director of Marketing and Communications for Invest Ottawa and Area X.O. And for those that are not familiar, Area X.O is an Ottawa-based research and development facility featuring a private testing facility, unique smart city infrastructure, physical and simulated assets, and one of the most advanced communications infrastructures in the world. All this allows our clients to test and validate exciting new technologies across all sectors. Which brings us to today's seminar focused on mastering robotics through simulation. Today, the Area X.O simulation team is thrilled to be joined by two of our expert partners. Representing Indro Robotics, we are joined by Vice President Peter King. Indro Robotics are really at the forefront of emerging autonomous robot and drone technology. Also joining us from Ansys, the leaders in simulation software, are Hao Hu. He's the Regional Sales Manager for Canada. Application Engineer John Cobble is with us today, and Ryan Gillerin. He is the Senior Application Engineer with Ansys. Joining our simulation program partners and leading today for Area X.O is Simulation Engineer Hossein Sami, also supported by Dr. Barry Stout and Business Operations Manager Rachel Petra. Before we begin, here are a couple housekeeping items. Please enter your questions, comments throughout the seminar by scanning and using the QR code that will be coming up on your screen. We also have a specific Q&A period following the presentations, and we will have a couple polling questions we will be asking. The first will go up in just a few minutes, and it's going to ask which sector you represent. The poll will close in a few minutes, and the second question will appear towards the end. To start things off, I would now like to introduce Peter King. Peter is Vice President Indro Robotics, and he's going to present on a new zone located at Area X.O. Peter, we're looking forward to it.
Thanks so much, Patrick. I really appreciate it. As always, we appreciate being invited to these conversations, and very excited today to talk a little bit about DARTT and what that is. But for those that aren't aware of who Indro Robotics are, we are a robotics organization headquartered in BC, but we do have our main technical office on site at the Area X.O facility, mainly because of the infrastructure that Patrick just talked about. And we're pretty excited to have been involved in building the DARTT site, DARTT standing for Drone and Advanced Robotic and Testing Facility, as it's right up the alley of what Indro Robotics is all about. So our mission is to invent, enhance, and deploy robotic applications and products to solve some really interesting, or provide some interesting solutions in the dirty, dangerous, and mundane environment. So automating these are what we do best, utilizing both drones and ground vehicles. But jumping into DARTT a little bit more, today we wanted to talk a little bit about what DARTT is. So DARTT is a new facility. It's launched. It's the only one of its kind here in Canada, and something that we believe is going to make a big splash in the robotics industry. It's basically an outdoor physical simulation environment that allows organizations from all over North America to come on site and test their applications or train on applications in a safe and cost-effective way that we've never been able to do in the past. Traditionally, as we build out these solutions, many SMEs and organizations creating this advanced technology have had to find their own way in where to test and train on these facilities. So one of the things that we really, coming back to the actual facility itself, you can see a few photos here of the facility. We've set up a number of stations here at the DARTT site. This is all based on input from organizations from all over the country and based on real feedback from what is important. So you can see that we have a number of obstacles, but also surfaces that organizations can utilize to test their applications, test their robots, test their facilities, but also train on these in in every application. What's very interesting about this facility is that it is flexible in what we can set up so that we can actually train on specific environments, whether you're in the public safety sector, agriculture sector, manufacturing. There is the ability to bring out and test in the way you do things. So you can see sand and gravel and different terrain. We have obstacles that we can utilize. You'll see that we've put in 2 types of curbs for those looking to test in real world environments. We have a very large drone net. So those struggling with where and how to fly advanced drones in a safe, cost-effective manner is on site here. Things like ramp testing is really important at these facilities as well. So having this safe place that is cost-effective for SMEs and other organizations all over North America is becoming extremely important. We'll talk a little bit about why. Why is this so important? Why does DARTT matter? Well, the first thing that I would tell you is that the robotics industry is growing at a very rapid pace. As we start to see new challenges arise, we're seeing automation in every market and every vertical at the moment as we look to solve some challenging problems that are either hard to deploy or hard to employ. So we see this very large rise in manufacturing automation, agricultural automation, autonomous vehicle applications, whether it's on road or others. The drone industry is expected to hit $38 billion this year. Power utilities and facilities managers are all looking to automate some of their processes. And until now, there's never been a facility that we can bring this technology, the regulators, trainers, and more together to work on some of these very specific problems and have these conversations about how to deploy, where to deploy, safely deploy. And DARTT does that. It brings all of these things together. It helps the conversation from a automation marketing point of view. It brings in the regulators so that we can see, so they can get a better understanding as to what technology is currently available. It's very difficult for them to keep up with. And you can see that we've strategically placed the DARTT site in Ottawa, which is home to more than almost 75,000 engineers and scientists, which is by and large the largest population per capita of technology employees in North America. Okay. So we do find that there are some significant benefits to a number of groups. And what we're excited about is DARTT bringing them all together, where they've traditionally had to go out and work in separate arenas. So those 3, I would tell you, are SMEs and organizations building the technology, the training and technology market for people to actually get into the industry as the industry continues to grow, and the regulatory bodies obviously are having a difficult time keeping up with the technology that's being built. So let's talk a little bit about the benefits to small and medium enterprises. This brings me to a story about Indra Robotics from back in our day. I would tell you that when we were a young company testing some of our drone technologies that maybe even weren't quite ready yet, we didn't have access to a facility like this. So we used to have to knock on doors of farmers to see if they would let us utilize their farmland to test some of our equipment. This is obviously inefficient and not an ideal situation for both the farmer, but also the robotics organization. So having a facility like DARTT, whether you're flying drones, you're working on autonomous vehicles, if you're in manufacturing or any of these markets that we just discussed, the benefits are significant. To have all of these things in one place to complete this cost-effective testing and have the flexibility to do it in a manner, in this local manner as well. Okay. I would also tell you that the robotics industry training and education is something that DARTT is really impactful for. The simulation, this physical simulation environment allows for not only testing of the robots, but those looking to get into a technology industry can sometimes struggle to figure out how to get in. So the example that I'll use is the drone industry. You know, becoming a drone pilot, where would you go today? How do we standardize on that process? How is that training done? What does the certification level look like? And where can I go to get this next level training? I can tell you that DARTT in this physical simulation environment does allow for people to come in and communicate with the staff on site to get some of this certification and training done. And it's an excellent site to allow people to get hands-on, for example, with that drone cage. And this will continue to grow as we look at new applications and new types of roles necessary as we get into these robotics operators and get into new and advanced fields that are underemployed at the moment. So DARTT is a great opportunity to bring both the manufacturers, but also people that are looking to work in that industry together in one site. And then the last piece that we talked about or mentioned earlier is the regulatory advantage of a place like DARTT. So when we look at regulatory bodies like Transport Canada or NAV Canada or a myriad of the other municipalities out there, would tell you that the regulatory issues when working with technology, advanced technology like we've got, is very difficult for them to keep up with. So traditionally in the past, we've just had to find space to go out and test and hope that we got it right. It reminds me of a story of an organization that set up shop in one of our major cities here in Canada, and the municipality was just unsure about how the technology worked. So they asked that organization to stop their deployment of their advanced technology that was doing some great work in that city. Having a facility like this, we can now bring together both the manufacturer and the regulatory bodies to understand what technology is being developed. We can showcase it in real time, we can see it, and we can look to certify these products, whether it's a certification for an operator or certification for the actual technology that we're deploying. And so this outdoor physical simulation environment starts with the team there at AVxcelerate and being able to bring people together within this industry to really advance the technology that we're developing. Certainly a critical infrastructure necessary for an organization like Indra Robotics. A little bit beyond the virtual simulation that we're talking about today, but I think everybody will see here in a moment how Sammy ties that in with his virtual environment that everybody can utilize before coming out to the site and actually testing their equipment. So with that, I think we're a little limited for time. So Patrick, I'll hand it back to you to introduce the next speaker.
Thanks so much, Peter. So we are excited about the DARTT Zone for sure, and we would be lost without the expertise that Indra brings to the table. So thanks to you and your team. We're now excited to head into the simulation environment, and I'm thrilled to introduce our Ansys colleagues. So we've got Hao Hu, Regional Sales Manager for Canada, and John Cobble, who's going to join. He's an application engineer. And guys, take it away.
Okay, thank you so much, Patrick, for the introduction. And Peter, actually, that was a very nice overview of the physical facility of the DARTT. So at Ansys, we're very excited to talk about the collaboration between AVxcelerate, Ansys, and Indra Robotics. For us, right, Ansys primarily engaging in the virtual prototyping, virtual testing, capabilities actually to complement the physical test here. So again, my name is Hao. I'm the regional sales manager for Canada. I just want to give the audience a quick overview about Ansys and the simulation technology we're providing to Canada and North America. So, as you might be seeing, like a lot of companies really focus on digital transformation, industry partners, etc. So simulation, virtual prototyping has become an important component of any digital transformation journey for a company to conduct R&D activities. Traditionally, we're focusing on detailed design on optimization and our software are typically used by specialists. But there's actually a big trend over the last few years, really enable virtual prototyping and have this shift left trend where we're actually helping at the early stage of the design, because 80% of the development costs are locked in early in the concept and the design stage. So leveraging the Ansys virtual prototyping platform, engineers testing their products can realize more innovation, faster cycle times, and reduce the cost and risk. So below are some of the metrics we actually extracted or feedback from thousands of Ansys customers, where you typically see multiple times of the reduction in development time. And for a complex system, sometimes you can reach 1,000 times of time saving. And as most of the organizations right now have a sustainability initiative, the green initiative and the carbon free. So actually, by selecting the optimized better material, we can realize up to 25% or more weight reduction and optimize the product design, and of course reducing 10 to 20% R&D cost. So Ansys, we started 50 years ago focusing on physics simulation, but over I would say the last 10 or 20 years, we really accelerate this vision to provide a complete virtual prototyping capabilities, adding different physics, but then also providing the system simulation. So the past 10 years, we actually acquired 20 different organizations adding to our platform and really enhance our portfolio to provide the best simulation environment possible in the market, and to helping and also collaborating with our industry partners such as Microsoft, SAP, AWS, Autodesk, but then most importantly, AVxcelerate and Indoor Robotics. And so for the DARTT project, as I mentioned earlier, we're coming in to focus on the virtual prototyping aspects and primarily focus on the aerospace and automotive industries. Our platform can be used everywhere, any compute platform, such as on-premise or on the cloud. And so imagine yourself, right? This is actually more like a digital twin of the physical asset in the virtual environment inside the computer. With that vision, I want to introduce our next speaker, John from Ansys team, and he will be able to give you a more description on how we actually collaborate with the DARTT project over the last few months. John, please take away.
Sounds good. Yeah. So I was saying, I'm Jonathan Coble, application engineer representing Ansys. I work with my rockstar AV teammates and Ryan Gillern and Jack Zai. And we had the pleasure of working with Sammy and Barry from AVxcelerate. And we'll be covering asset preparation for AVX sensors. And right away, we'll just touch on the two software platforms that AVX asset prep goes into, which is AVxcelerate sensors and headlamp. We didn't use headlamp for the DARTT project, so we'll be mostly focused on sensors. And as Hal touched, and Peter as well in the past, we want to test in physics-based simulation environments to obtain accurate results, not only far faster than physical prototypes, but we also can safely reproduce things that are not easy to obtain in the real world, specific custom scenarios, other things that are high risk. And our sensor outputs are optical camera, thermal camera, radar, and LiDAR. And so what we're aiming for here is virtual world modeling. And again, to touch, we're creating a physically accurate digital twin of our test environment. So Peter shared the actual pictures of the site. And what we're aiming to do is create a digital twin of that environment so we can get in there and test and get validated results. So we can accurately model sensor environment interactions. We also have an open API to create our own custom workflows and synchronize scene variation. And a big seller too is we have a library of physics-based assets. So we have our own scan materials for surface states and dielectrics and our thermal properties as well. So we can get as close to the real world as we can in our simulation. And then we also have our sensor pipelines that are totally customizable, and won't go too much into depth there, but you just kind of see them, and we'll move on. So here we have the DARTT environment work. So the first step is to have some pre-prep before going into AVX asset preparation. So first step is to get into any kind of standard 3D software package. For this, we use 3ds Max and Blender. But the work I had done was in Max. So what we initially do, we take the imported models, we break them down, and we clean up the geometry for better simulation performances. Then we texture map. So you can see at the very top right, a little animated GIF of kind of what we mean by that. So essentially you take a model, think of like a product box, like a cereal box, for example. So you first have to lay it out flat to print on it, and then you assemble it together. So that's essentially what we're doing digitally. So we're breaking down a model, and we're going to unwrap the UVs so we can apply textures to it, essentially color and text maps and textures, etc. Then we prep the materials before we go in. So we give it proper naming, a proper submaterial breakdown. So we have all this extra control in AVX, so we can control all the materials on a sub level. And then we first have our initial AVX import. So we ensure a clean import from our 3D software standard packages. We make sure the materials are broken down appropriately, so we have control as we need it. We import any external assets, textures, any extra models, and then we also tag the assets as to what they are, as far as props, lights, road signs, whatever. Very simple for the DARTT track, as we're not on a highway, so very straightforward, mostly all props. And then we next step is to set up the lighting. So we first start with the natural sky, and we kind of get our initial sky settings for the simulation. Then what we want to do is we want to get a nicer looking sky in there. So we swap the natural sky, keep the settings, but we swap it with a nice HDRI. And since we're still based off that natural sky settings, we drop in a directional light to kind of simulate the natural sky and provide the HDRI with some extra detail. And then we just make our shadow adjustments as well. Third step here is this is where we get into the details of the materials to really provide good simulation results. So we first start, all the imported models usually come in with the diffuse normal from the exports from the standard package, but we'll apply that and if needed. And then we go into the physics-based materials. So that's where we apply our surface states, which are scanned BRDFs of actual world objects, and then our dielectrics as well. And you can see, for example, too, we'll have like the little picture there. We have that submaterial breakdown of, we have the gravel pit. So we'll have a gravel, a wood, and a concrete, and we'll have control over all those materials and be able to apply exactly what they need. And then we also apply the thermal properties as well. We have a mathematically accurate reference chart for emissivity range, reflection coefficient, and shininess. So final stage here is to get our sensor outputs. So we set a vehicle on a trajectory around the zone. We create our sensor configs for that vehicle for camera, radar, and thermal camera. And then we run the AVX simulation. And then afterwards, we validate the results and see what we get. And we had some good initial test runs before passing it over to Sammy and Barry.
Perfect.
Thanks, guys, for that. So it's unbelievable how far we have come, and it wouldn't have been possible without the Ansys team working hand in hand with us. So we're now fully in the digital and simulated environment, and we're going to ask our simulation engineer, Hossein Sami, to show us some of the scenarios that are possible.
Yeah, hello everyone. Thanks so much for that with Peter and Hao and Jonathan. The team has been very great to work with. And what we try to do with the AVxcelerate team is really tie in together not only the physical asset, but also the simulation. This allows us to support more clients than ever before, and also support them earlier in the process before they even show up to our site. What I'm sharing on the screen here now is our Robotics platform. This is the robotic systems simulator. One of the first things I want to say is that robotics is very general. It's not limited to just rovers or just drones. It is an all-inclusive category that includes all of these platforms and much more. What Robotics allows us to do is capture all these different types of vehicles and mimic their performance in real world environment. So here you can kind of see Weebot's imported model of the DARTT zone. So this isn't the accurate Ansys thing, but what we do in this environment is we define the robots before moving on to simulating the sensors on it. There's two robots we're going to be focusing on for this demo, just for the sake of time. It's going to be a wheeled robot, a rover, as well as a drone. So I'm going to start with talking about the drone and kind of how what this platform allows you to do if you're designing your own drone and you want to determine its performance, as well as what kind of sensors to include and where. So this platform allows you to define the world that you're simulating in. So there you have, you can determine the types of physics that you want to see. This allows you to manually, change the gravity. If you want to simulate other planets, you could turn on or off air resistance. It really lets you get into like the friction as well and contact properties to determine how complex of a simulation you want to get. So for here, we're not going to do anything too crazy. We've imported this robot into this environment, and we've imported the DARTT site. Moving on from that, in the robot, we can see that the DJI Mavic Pro has a standardized model that we're able to use, and we're using this in our twin right here. So in the controller of the device, we're able to customize exactly what we want it to do and what sensors we want to include. Right over here, I have a very simple PD controller implemented. So you can kind of see it looks for your keyboard inputs to determine what you want the drone to do. And then based on the specific gains we have on the controller that you can customizably tune, it's going to respond to what I want it to do. So without too much further ado, I'm gonna get this started to kind of show you what we're able to do. First in the Weebot's environment, and then I'll show you what we can do with the help of Ansys. So here, I'm going to start up the drone. And you should be able to see, boots up, yeah. So here you can kind of see the drone has taken off. We can see a view of the camera on the drone and what's going on there. We're able to fly this drone as we please. So right now, this is me flying the drone with my keyboard. And of course, as you can see, drones get pretty complex with regards to the different controls you have. You can go left, right, up, down, back, forth, and so on. This Weebot software allows us to control all of these, and not only just control it, but it also lets us push the system to the limits. What I mean by this is when we're testing our drones, we want to know, okay, at what stage does it crash? At what stage does it stop working? I gotta move up here so I don't crash. Sorry. Okay. Yeah. So what the Weebot's platform allows us to do is if we wiggle the drone back and forth too fast, like right there, you can see the drone will fall out of the sky. What this shows you, what this demonstrates is the physics is being simulated, and this lets you push the system to the edge of failure. Doing this in a physically real platform would be unrealistic and also very costly. Right there, if I were to perform these series of control inputs to an actual drone, it would have crashed and I would have had to replace all the parts, and Peter would be very upset if I was using his drone. But yeah, so that's kind of gives you a taste of what's going on. Now, to show you what the help of Ansys is in this environment, I'm going to enable this series code that Ansys has provided. And we'll just restart the simulation again. Okay. Now it's going to take a second to boot up while we let the digital twin load up, but I'll kind of talk to what's going to be demonstrated. What we're going to show is just the optical cameras, just because that's the fastest to render. But we are also able to simulate different sensors like Jonathan was talking about. We're able to simulate LiDARs as well as radars. And he had some sample data for those different sensors. And we have more samples on our online portal if you sign up for the discovery. So while this is loading up, what the plan is here is we're going to take the drone. Oh, looks like it's almost ready. Let's see. I'm going to move the Weebots out of the way since we've already seen what that does. And let me bring forth this view, which is what we'll want to focus on. Dun, dun. Yeah. So right here, you can see the drone starts at the same place, doing the same sequence. I'm just moving the screen for Weebots onto the other side. We're able to see what's going on in the Ansys platform. So here again, you can see the drone's able to fly around, but the details of the environment is much more. Okay, I did not do that. What? Oh no, I'm sorry. This is why I'm a software, not the pilot. Sorry, guys. I'll have to reset that because I crashed the drone. But it gives you a taste of what's possible with the Ansys Twin. What we were able to get is it's okay. You can do this reshot. But what we're able to do is get detailed information about what the camera can see, and we can feed back this information into the controls of the drone. What this lets us do is develop autonomous algorithms where the drone can avoid obstacles in real time, and we can simulate this in our digital environment before we go for the actual experimental flight. Once this loads up, let's see. Yeah, I'm just waiting for the aviator. I'm going to focus on flying a little more so I don't crash it this time. My apologies, guys. Okay. Yep. So right here. Yeah. You can see the environment that we were looking at and what Jonathan was sharing. We have the wooden platforms with the steps and so forth. We have the 2 pits with gravel as well as sand, as well as the concrete sidewalk, all the obstacles, and of course the netted drone cage. Yeah. It is difficult to fly, which just reflects how hard it is to fly the actual drones. And we do have training scenarios that we intend to do with the support of Intro. Using the drone targets that are visible here on the screen, we can allow pilots to fly around and actually see if they're able to orient the drone into the correct position and actually look into these buckets and identify what's going on in there. So this allows us to remotely support the training of pilots in the digital environment for flying drones and ensure they're comfortable with the platform as well as before they actually go to fly the device. Now, I think we've done a decent amount on drones, so let's move on to the other platform that I wanted to talk about. I'll bring back the Weebots. So we're going to talk about the rover next, right? So one thing I have to change here to let us view the perspective of the rover. Yeah, so the rover here is a 4-wheeled robot that uses slip steering. The wheels aren't steered, but they turn in opposing directions in order to allow it to turn. What we're going to do is take this rover and drive over one of the obstacles. So again, we'll start the simulator. And one of the things I want to emphasize is how fast we're able to get these simulations. So as you're seeing, when we're flying these robots or drones, we're able to get the data from the sensors in real time. This is an amazing achievement because simulation is typically known to take an extensive period of time in order to get accurate results. With the help of Ansys and their years of experience, we're able to support clients at the rate of minutes or even seconds to get them the data. We're able to run simulations to collect hours, days of simulation of data before clients for the clients to conduct whatever machine learning algorithm or so that they wish. So here we have AVX. Let me full screen this, and I'm going to drive the rover this time. Yeah, so you can kind of see we're able to drive. I'll bring back the other screen shortly as well. So yeah, we're able to drive around the environment. And let's see, here's my other screen. You can kind of see my robot driving there in red. So we're able to navigate through the environment in Weebots. So Weebots does the actual motion of the vehicle. And then Ansys simulates all the different sensors that we want on our device. So I'm going to drive this robot towards one of the obstacles, and we'll swap back to the Ansys view shortly. We move this out of the way. Yeah, so you can see we're getting there. Yeah, and we're going to try and climb the platform right there to see if this works. I think I'm not there yet. A little further. And yeah, okay, I'll turn. Yeah, so right now I'm trying to climb into the gravel pits, and you can see the robot's trying to climb over it. And oh my, okay, oh, okay, it recovered itself. And I think I've hit the pole, so it's stuck. So I just want to kind of show you what's going on in the Weebots environment as well at the same time. So here you can see the robots, it was able to just climb over the lip, get into the gravel pit, and we were able to simulate the entire dynamics of climbing over that. And now you can see it kind of going through the pit, and I'll try to drive through it, but this kind of gives you a feel of what's possible with our platform, right? We're able to input different robots and simulate how they're able to navigate in this environment and so forth. Awesome. So in the interest of time, I'll try to move on to some slides so we can talk a little bit about what's going on here. Yeah. So, yeah. So as far as our simulation products goes, we're able to simulate much more than what's been shown today. We're able to simulate mobile robots in high traffic areas. So this allows you to test for collaborative applications with multiple agents as you would have in a city, and determine whether your system is able to operate safely and coordinate with the other vehicles, whether the other vehicles are cooperative or not. We're also able to simulate connectivity based on the antennas you have on your system and how it's able to communicate with other vehicles as well as infrastructure. We're able to simulate the performance of different sensors. We demonstrated the performance of cameras, but we're also able to do it for LiDARs as well as LiDAR and radar. And we have content demonstrating that on our Discovery platform if you sign up. We're also able to simulate the thermal integrity of electronic components. This lets you determine, especially in a case like Ottawa, where we have extreme weather, very hot to very cold, whether your system is going to be able to handle this. We're able to not only determine whether it's structurally capable of handling it, but also whether the electronics are able to maintain their signal integrity at these extreme conditions. And like we were demonstrating, we're able to implement custom control algorithms and determine the performance of drones. Now, this is not only for small scale as we've shown here, but we can also support the larger missions of fixed wing drones flying across Canada anywhere, or actually anywhere in the world. So what we really want you to take away is that if you can think it, we can test it for you. So one of the main things I want to emphasize is why we should use simulation. Simulation allows you to adjust the characteristics and dimensions of your model real time. If you were to actually physically make the model and you were to determine that, okay, this is not going to work, it's a large barrier of time as well as cost and effort to remake everything physically before you can test it. Simulation allows you to change things with the clicks of buttons. Like I showed you, there was gains for parameters. We're able to just modify a number, hit play again, and simulate within a matter of minutes. It also lets you optimize your design to find the maximum performance, minimize cost, expedite production, or anything else that's very important to you. The importance of being able to effectively communicate your results is invaluable to a lot of these startups, and to demonstrate to their clients how their product is different from others, as well as how it's going to be able to support people and fill a need. And the last thing I want to emphasize is we're able to simulate weather conditions such as day or night, rain, snow, fog, etc. And we're not at the limitations of actual physical weather in order to do these conditions. Like we were showing with flying the drone until it actually failed, or the robot until it tips, we're able to push these systems to their actual limits before we hit stop. with that, I think I'm going to be passing it back to Patrick to do some closing remarks.
Thanks, Sammy, for that. So, Sammy, you redeemed yourself with that second flight for sure. And you can crash as much as you want in a simulation environment, right? Good job, Sammy. So we're going to jump into the Q&A portion of the webinar. So as we bring everyone else up, just note that if anyone has any questions, there was a QR code that you can scan in terms of inputting any of your questions. If by chance we don't get to all of the questions, please send them to simulation@areaxo.com, and we will make sure that they are answered either today or into the future. Okay, well, hi guys, welcome back. We're going to jump into some Q&As here. And Audrey, you can bring back Sammy and Peter too if you want. Great. And thanks everybody for putting in any of the questions that you had so far. To get things started, maybe we'll just ask the first one then. So how can simulation help in the design and optimization of robot movements and behaviors? Anyone want to grab that one?
Sorry, could you say it again?
Yeah. How can simulation help in the design and optimization of robot movements and behaviors?
Okay, yeah, I can definitely talk more about it. So one of the things that was the case, as we saw with the wheeled robot, is what type of motors are we using? What type of wheels are we using? Is it suitable for the obstacles that we're looking at? What we're able to do in simulation is we're able to, by just typing and defining the torque that we need, we're able to freely choose any motor and upscale or downscale our design to whatever fidelity that we want. We're able to test this then and see whether it's able to drive over the obstacles. We're able to test different friction models, tire models, you name it, right? So we're able to do all these tests at a matter of clicking buttons, and we don't have to spend $1 to actually purchase these parts, wait for them to ship, and so on. Another thing for the drones is we can choose different types of propeller, different types of motors, and so forth. So yeah, it lets you change your designs in all these ways, and also sensor placements and what might be better to detect different obstacles compared to others. Yeah, I could go on.
Yeah, if I could jump in here, I think you had kind of already alluded to it, Patrick, when Sammy had, running into an issue controlling the drone and crashed it. If that was physical drone, that costs a lot of money, a lot of time to get that into test. And when you do that in a simulation environment, all you have to do is stop the simulation and run again, and you can start right from the beginning where you left off. And as Sammy also had alluded to with the sensor validation, yeah, that's a big part of it as well. Looking at your sensor output from the different sensors involved in the stack. Your camera, your radar, your lidar, thermal. You can validate your output then and there, and how your algorithm for understanding that data that's coming from that output is affecting your robotic, your drone or your ground robot, in real time, and understanding that sensor output and how your robot is responding to it will help you fine tune those algorithms. So then when in the physical world, that those sensors are already validated in your algorithms for how it's responding to that sensor, input is already validated. And so those crashes become less likely.
Exactly. Yeah, 100%. Can't echo this enough.
Love it. And who doesn't love a do-over, right? So, thanks, Brian, for that.
Risk-free.
Okay, so next question then. So Avon Alex is at Pothin is asking, can the Ansys virtual prototyping system be used to test the robotics control software?
Yeah, absolutely. As I just alluded to, when you have your physics-based environment and you have your physics-based modeled sensors, the output that you're getting from those sensors, are true to form. And, when you plug in your perception algorithms for those different sensors, you can validate the movement of your robotic systems. Kind of just touching on what I had said in the last question there.
That's great. Maybe Audrey will take one more question. So Derek Bose asks, can the environment be brought into ROS, or can ROS compatible robots be used in the simulation environment?
Yeah, I can talk to this a bit because we do quite a bit of work with ROS in our on our site. One of the most complex robots that we have is our autonomous car, which is Lexus. And we've integrated LiDARs, radars, optical cameras, thermal cameras, and so on, all on the vehicle, as well as roadside units. And this is all integrated in the physical hardware using the ROS platform. What we have implemented at AVxcelerate is we're able to streamline the data. So over 5G, stream the data from the live Lexus and import it directly into Ansys AVX. What this lets you do is in our digital twin, as the car is driving, you not only have the physical sensor data, but also the simulated at the exact same location using the GPS coordinates. The results are scary similar, so it is really good.
Yeah,
Awesome.
and on top of that, one of the advantages of the AVxcelerate sensor simulator is that it's driving simulator agnostic. That makes us a lot more flexible. So, in Sammy's demonstration, he was showing the connection with Weebots, but our AVX system can be combined with any driving simulator, whether that's one that's commercially licensed like CarMaker, or one that's free of use like Carla or Weebots, or even if you have the ROS system built in for your robotic control, we can build a connector to connect into it.
Perfect.
And you could potentially extract the FBX right out of AVX Asset Prep too. So if you had something where you were struggling to find a connection, you can extract the FBXs right out of the assets.
Great. Thanks, guys, for feeding in on that one. So we've taken note of all of the other questions. We will respond to each one of them to the entire group to let them know of any of the answers that came up today. And thanks, guys, for answering those questions. We're just going to conclude quickly here that we want to thank all of the Area X.O team members, Peter, Hao, John, Ryan from our important partners, all for enlightening us today. These are the kind of discussions and kind of scenarios that we are running on a constant basis. And if you're not already a member of the simulation community, please consider doing so. Visit our website or use the QR code that's going to go on the screen to register for the free simulation portal. And you'll receive unique content and sample simulations that could be of interest to you. And then if you have any other questions or need anything else or are interested in the future of this simulation environment, contact us at simulation@areaxo.com. So thanks again, everybody, for joining us today, and have a great day.
Thank you so much.